A couple of projects that we've just kicking off at the moment. It's called Unlock CP. It's really to try and unlock the spasticity that children with cerebral palsy have. As far as we understand, is that due to a brain injury, they probably end up in a wheelchair for the whole life. Family needs to look after them. This is sort of the area that we work in, called Bioelectromagnetism. We can do things like take measurements of fields like the ECG or the EEG, or we can measure the intrinsic properties to design better equipment as well. There's lots of work to do around prevention of these sorts of disabilities, intervening early, restoring ability. For radiofrequency ablation, you need the electrode at the end of the catheter to be in contact with the heart wall, and the highest point of heat is right at the tip there.
Basically, myconography is a technique by which we can stick a fine needle through the skin into a peripheral nerve in awake human subjects. So what we've been doing for the last 12 years or so is recording muscle sympathetic nerve activity as well as skin sympathetic nerve activity and correlating those bursts with brain activity as recorded with functional magnetic resonance imaging. So MSNA coupled fMRI and SSNA skin sympathetic nerve activity coupled fMRI allows us to identify regions of the brain that are basically coupled to the bursts of muscle sympathetic nerve activity. To conclude, these studies have shown that with the brain imaging, that higher order processing contribute importantly to these autonomic control. But these areas are influenced by higher areas of the brain. And basically, this top-down control gives us the ability to modify our physiology according to behavioral or cognitive tasks.
But it's all about these things that carry signals inside your body called neurons. We call it neuromodulation, the altering of the activity of nerve cells. If you look at a bionic eye, or what's called here a retinal stimulator, that was invented in Australia. And they actually implanted this device in a woman that had what I believe was retinitis pigmentosa. And she said that she could see a bright light where there was nothing before. And so quite a remarkable achievement. I kind of doubt that it was actually doing a great deal. So here's our idea. This is, it sits behind the ear, antennas on the back of their head. And that's for sending data and information, and power rather, to the implants. And we have this little cable that runs behind, underneath the skin from behind the ear to the eye. We have our cable with our electrodes that go around into the back of the retina.
Particularly interested in mental health is really worldwide. Mental health problems are now the leading cause of disability in young people. 75% of all mental health problems will arise before someone reaches the end of adolescence. We're really not very well equipped in dealing with them. What processes should we target? What is this ideal sweet spot? So first of all, I want it to be a process that we can actually change. It has to be malleable. And then second, the process needs to have downstream effects. We get people to read a sentence and make a semantic decision about whether it's semantically accurate or not. And at the same time, we get them to remember a word that's presented at the end of the sentence. These sentences are either neutral or they're negative. So what we did is we designed a working memory training task. We found there was no difference in how much they reacted to a negative film clip.